Yesterday we practiced computing actual lengths from a scale drawing, and today we are looking at various shapes to then use corresponding sides to find missing sides. So let's go ahead and look at this problem below. It says quadrilateral MNOP is similar to quadrilateral SRUT. What is the value of x in centimeters? So if we look at these shapes and see that they are similar, then we know this means they are proportional. So I'm going to go ahead and write similar equals proportional. So go ahead and add this to your notes. Therefore, we know it has a scale factor between these two shapes. And so we know that one is a scale drawing of the other. Since we don't know specifically which one, it didn't tell us, then we're going to go from left to right. Therefore, this one is the scale, or the new, and this one is the original. So if we're looking from left to right, the original is going to be the larger quadrilateral, and the scale drawing is going to be the smaller one. So before we can compare these two shapes, are these shapes facing the same direction? No, they aren't. One, they're kind of like facing inwards. So I'm going to redraw the scale drawing so that it matches the original drawing. So let's just redraw the first one below. So I have more space, and it's NOP and this one's 12 centimeters, and this one's 14 centimeters. Okay, so now I need to draw the scale drawing. So I notice that a vertical line is on the left in the original. So that means the scale drawing needs to then be flipped so that the vertical line of 8 centimeters is also on the same side. And so this one's RS, and that's 8 centimeters. There's also a diagonal line going from left to right, decreasing. So I know line UT goes on the right. So it goes like this. So this is UT. Well, I know line UR is still on top. And then line ST is still on the bottom, which it doesn't look smaller. So actually, let me make it a little bit smaller because it looked like the exact same size as the other drawing. There, so now it's a little bit smaller, and this is T. And then this is what's missing, is the X. Okay, so now that we have redrawn the images, we can now match the corresponding sides by using symbols or colors. Since I have both, I'm going to use both. So I see that MN clearly matches the side RS, right? They are both the straight vertical lines of our shape. And so I am going to circle them with a red circle. I now also see that MP matches with ST. So I'm going to put a little blue triangle here to show that those two correspond or match. And then I also see that NO matches with RU. So I'm going to put a green square. Okay, so I have now put 3 different symbols to show the different corresponding sides that we have in our shape. So how can we now find the scale factor? Well, I know that we divide new over original, okay? And we have already identified this as the original and this as the new, or the scale drawing. Okay, so we can choose any pair of sides to find the scale factor. But since I only actually have one pair of corresponding sides where I know both sides, I can only use MN and RS. Okay, so MN and RS. The side on the new shape is 8, and the side on the original shape is 12. Now, I could simplify this fraction, or since we've been doing this practically every day, we can also divide using bow tie. Bottom out, top in, and I'm already going to add my decimal and my 0 because I know 12 does not go into 8, but it does go into 80 6 times. And after I borrow, I get 8 again, and I bring down a 0. Oh, well, I see that already we are showing a repetition or a repetitive pattern. So I know our scale factor is 0.6 repeating. So now that I found the scale factor, how can I use it to find this missing side, right? That's the goal, is to find the missing side of X. Well, I know that to find the new dimensions, we multiply every original dimension to get to those new dimensions by the scale factor. I'm sorry, let me say that again. We multiply the scale factor by every dimension on the original shape to get the new dimension, okay? So that means to get from here to here, it is multiplying by that scale factor. So if we set up our table, we always have the original, and then our equation would be multiplying the original by the scale factor to get the new. Okay, so we know the original dimension that they have given us is 14, and the new is x. That's what's missing. Okay, so we need to multiply the scale factor times 14 to get to the new. And now this is why I suggested potentially simplifying this fraction instead, because 0.6 repeating, unfortunately, we can't show that in multiplication by multiplying over and over and over again. But if I simplified, I would get 4 over 6. I simplified again, I would get 2/3. So I could also just multiply 14 times 2/3 to get a more precise answer, even though multiplying by 0.6 would get us a close one, but it would just be an estimation. So I'm going to multiply by the fraction to try and get the most specific that I can, or the most exact that I can. And I get 28. In fact, let me lower this because now it's getting too close to the other calculation. And we get 28 over 3. And then if I simplified that using bow tie, 28 doesn't go, or 3 doesn't go into 28 exactly an exact amount of times, but it gets pretty close. And if I left it as a fraction, or in this case a mixed number, I see that x is 9 as the whole number, 1 as the remainder, and 3 as the pieces we cut it into. So the new dimension is 9 1/3 centimeters. So now we can answer our question. It says, what is the value of x in centimeters? So x is 9 1/3 centimeters. Well, what would I have done if I was missing an original side? So for example, let's say we had this side, we had 9 1/3, but we were missing 14, right? This was missing. Well, if I multiplied the original dimension to get the new dimension, then I would have to do the opposite or divide to get the original side. So let's just stamp. To find the new dimension, we multiply. So original times the scale factor gets us the new dimension. Now, in order to find the original dimension, we would have to divide by the scale factor to get the original. So go ahead and add this to your notes because this is going to be important as we practice a few on our own.